Jai Hind all of you. Today I will deliver lecture on subnetting. I am myself Deepti Arora, Assistant Professor of AKGEC Engineering College, MC Department. So what is subnetting? First of all, we should understand what is subnetting. When we have a bigger network for around in this IP addresses are of around thousands of IP addresses are there, or millions of IP addresses are there, and we are allotting these IP addresses to a organization, and that organization is not eligible or does not want such enough IP addresses. So many of the IP addresses got waste. So what they will do, they share those IP addresses, those network with some other group or organization, so to avoid wasting of that IP addresses. Another view for that is, if you consider this is a flow diagram for an organization in which they are managing the business solutions. In that there are many different departments. Suppose there is a marketing department, software department, help desk, setup code, programmers, training department, support center, etc, etc. Many of the departments are there. Some of the departments have been taken care by third party, and some of the departments having some secure information that the organization doesn't want to share with any other department. Then what they will do, they will prefer some network that does not do sharing at all, that does not do sharing between the departments of the organization. So they want different networks for different departments. So what they do, they purchase a bigger network for themselves, and then they distribute or divide that network into different sub networks, so that there the privacy should remain. The third party should not know what the other departments are doing or what the organization is managing. So the main focus on the subnetting is to provide the wastage, so to avoid the wastage of the number of IP addresses, and to distribute the IP addresses to different departments of the organization. So here are some advantages of subnetting. First one is, it improves security. That is, if third party is there or different departments are there, the organization want to maintain some security between these departments, so it can be done by subnetting. Another one is, maintenance is easy. If there are millions of hosts in an organization, million of PCs are there in an organization, and millions of IP addresses are there, so to manage those IP addresses in a bulk is a very complex task. So by dividing those network into sub networks, it is easy to maintain those networks. What is the disadvantage? Another disadvantage is, identification of a station is difficult. How the identification of a station is difficult? Suppose you want to gift something to a family, one of your family member, and your father sent that gift to you to give that to their friend or your family member. You approach that house and you find that that family member is not reachable, because the house has different parts. In one part his uncle is there, in one part his grandparents are residing, so he does not know where to deliver that gift. Similarly, here is also the problem. The problem is that a packet arrives at the station, and it does not know to which sub network that station belongs to. So to identify that station is very difficult task. Another disadvantage is, not possible to direct broadcast from outside network. Suppose you are having this network, and this network is divided into 4 parts, and you want to broadcast in this network. So if you broadcast the any of the information in outside network, then it not be possible that all the sub networks will receive that information regarding that only this network receive this information. So it is not possible to broadcast from outside network. You have to search about your subnet, and then you have to broadcast at this network. Now, what type of subnetting are there? Fixed length subnetting and variable length subnetting. In fixed length subnetting, you have to divide your network into equal parts, that is fixed length subnetting. In variable length subnetting, you can divide your network in different parts. in different slot. It is not necessary to divide it in equal parts. You can, maybe it is consisting of hundreds of hosts and it is consisting of thousands of hosts. So it is a variable length subnetting. Now how we can do subnetting? See this. Consider the network having IP address 200.1.2.0. Divide this network into two subnets. You have to divide it into fixed length subnetting you have to perform here, and you have to divide this network into two equal subnets. How we can do this? First of all, consider the IP address first. Your IP address is 200.1.2.0. Now, first of all, identify the class of the address. How can you identify the class of the address? First, look at the first octet of the IP address. The first octet of the IP address is having the number 200, which belongs to class C. Or you can binary convert it into binary. After binary conversion, you will get the initial binary number as most significant bit as 110, which belongs to your class C. So this is a class C address. In class C address, the three most significant octets, the three octets, first octets are fixed. So which is a network ID. The class C, the three octets are fixed, which is a network ID, and the last octet is here is host ID. So what you have to do now, you don't have to consider this. You have to work upon the host ID only. You have to, the network IDs remain fixed, so you don't have to consider the network ID. You have to work on the host ID to divide the subnet. So what you have to do for subnet 1, the network ID is 200.1.2. Rest of the bit are here. We have to expand the last octet. In last octet, there are 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. Similarly, for second subnet, the network ID is fixed, and for the host ID, expand the octet. 1, 2, 3, 4, 5, 6, 7 and 8 bits are here. Now what we have to do? In network ID, for the first 3 octets, there are 24 bits, because total are here 32 bits of IPv4 address. So for 32 bits, 24 bits are here, left 8 bits we have expanded. For the rest 8 bits, the most significant bit of the octet, put it as 0. Now the network ID, it gets included in the in the network ID. Now network ID will be of 25 bits, 1 bit of octet we have consumed in network ID. And for the next subnet 2, we will put here 1. Now it is fixed. Now the network ID becomes of 25 bits for subnet 1 and for 25 bits for subnet 2. Now for the rest of the part, what we have to do for the rest of the part? For the first address, put all the octet bits to, remaining bits to 0. So rest of the bits are here are these 7 bits. So how many hosts can be the part of this subnet? We can calculate it by 2 to the power 7, because 7 bits are here. So 2 to the power 7. 2 to the power 7 is 128. So 128 hosts can be in subnet 1. Now for subnet 2, again 25 bits are in the part of network ID. Next, again 0, 0, 0, 0, 0, 0, 0. Now again the rest of the bits are 2 to the power 7. For 2 to the power 7, again it is 128. Now consider this, for the host ID, the first ID will be 128. This is the binary of 128. So what would be the first IP address? Your first IP address of second subnet is 200.1.2.128, and for the first subnet it would be 200.1.2.0. Now what would be the last? What would be the last address? The last address would be when you will put all the 7 bits to 1, 1, 1, 1, 1 and 1. Here also the last address would be when you put all the 7 bits to 1. These are the last, this will be the last address. So 2 to the power 7, total 128. When you put all the 7 bits, it would be 127. So 0 to 127, it would be total subnet number of hosts in subnet 1, and in second subnet this would become 255. So last address would be 200.1.2.255. Now the most important thing is the first address of a subnet is for identification of a subnet. So this would be the IP address of subnet. So whenever you have to broadcast something, you will use the last address, and for the first address would be used as the identification of subnet. So IP address of subnet is the first address of the subnet, and the last address of the subnet would be your broadcast address. Total number of IP addresses or total number of hosts that can join that subnet is 2 to the power 7, that is 128. Now range of IP addresses, range is from the starting address, that is the first address, to the last address. Similarly in subnet 2 also, the range of IP address is from starting address and the last address. Total number of hosts that can be configured is 128 minus 2. 2 is here, the first address and the last address. We have minus 2 IP addresses here. So number of hosts that can join this subnet is 126. Similarly here 126. So range of allocated IP address is from 1 to 126. 0 is eliminated here and last 127 is eliminated because they are the reserved one. Similarly in subnet 2 also 129 and 254. Now see the second one. Consider an IP address. We are having the same IP address here. Now it is saying divide it into 4 subnets. Now what you have to do? For 4 subnets, you have to fix 2 bits, that is 00, 10, 01 and 11. So 2 power 2 is equal to 4. So you have to divide in 4, you have to consider the 2 bits. Now the network ID is of 26 bits and the host ID would be of 6 bits. So how many IP addresses can be allocated? 2 to the power 6, which is equals to 64 in each. Equal, it is a fixed length subnetting. So equal number of IP addresses will be distributed to each of the subnet. Now range of IP addresses would be from again 0 to 63, because 0 is the network ID and last one 63 is the your broadcast address. Again number of hosts 64 minus 2, because 2 are the reserved one, the first and the last one. So now how many hosts can be configured is 62. Range of allocated IP addresses is 1 to 62. Now for second subnet, again it would be continued from here 64 to 127. Again 64 is the first, 127 will be the last. So what is the allocated range? 65 to 126. Now for the third one, again see here there was 127. Now the next one is 128 to 191. The 2 got minus for the reserved one. So how many allocated IP addresses would be? 129 to 190. Now consider the fourth situation, 192 to 255. Again 2 get less for the reserved ones. So number of allocated should be 193 to 254. So this is how you can divide your network into 4 subnets. This is the fixed length subnetting. Now consider the situation for last one, that is the variable length subnetting. In variable length subnetting, you have to divide into 3 parts now.
For three parts, I have considered the first part as the half of the network, and rest half of the network is divided into again two parts. You can also do that. You can firstly divide the first half of the network into two parts, and then the last one would be of half part. That is the vice versa of this situation. So here what you have to do, again for three parts, what you have to do, the same IP address we are considering. Here it is written that for three subnets you have to first contain the 126 host, and for second one it would contain 6062 in each part. So what you have to do here, 200.1.2. again rest of the bits, 8 bits, 1 2 3 4 5 6 7 8. Again here also 200.1.2. 1 2 3 4 5 6 7 8. Again for third subnet, okay. Now what you have to do, consider the situation where you have done the two partitions of a network. Here what you have done, you have fixed the most significant bit of the octet. That is, here it is 0 and it is 1. Firstly you have to do this, fix this most significant bit of the octet to 0, and for here fix it as 1. Now you don't have to divide this into two halves, but you have to divide this half portion again into two halves. So what you have to do, now you have to again fix another bit for these two halves. So for first one you have to put 0 for the next significant bit, and here you have to put 1. So now here it is 0 fixed, here 2 bits are fixed. So because we are dividing this half again into two halves, two equal halves, rest of the part would be the same. So what you have to do, for the first address 0 0 0 0 0, for the last address it would be 1 1 1 1 1 1. So here 0 to 127. again the rest of the bits are of 7 bits. So it would be of 2 to the power 7. So again number of IP addresses are here 128, and range of IP addresses from 0 to 127. The broadcast address is this, where the all rest of the bits are 11111, and IP address of subnet ID is 0. Again here consider here 2 bits are fixed, so the length of the network ID would be 26 bits, and for the host ID is 6 bits. So what would be the total number of IP addresses are here? 2 to the power 6. Again here 2 to the power 6, that is 64. And here again 0 would be the, if we put 0 in rest of the bits, it would be the first IP address. If we put 1 along all here 1 and 0 is fixed, rest of the ones are here. So it would be the last broadcasting here address, which would be 191. And again same 1 is the fixed, rest 1 we have put, it become 255. So it would be the last IP address of this third subnet. Range of IP addresses 122 to 255. Again total number of hosts 64 minus 2, 2 are for the reserved one, that is for your broadcast address and the network ID. And range of allocated is from 193 to 254. So what the question demands here, the first one contain 126 hosts, we are getting 126 hosts there, and other two contain 62 hosts each. So we are getting 62 hosts here and 62 here. So this is how we can divide the most number of networks where there are many hosts, there are IP address, lots of IP addresses are there. We can divide that network into small networks, so that the range of IP addresses can be distributed and number of IP addresses get wasted, not get wasted. Thank you.